Hello friends. Now today we are going to study a solution of the problem by using this queuing model, or it can be called as a waiting line theory or the waiting line model. Okay, same is the name but just with the different context. Okay, so let's take the first problem to solve by using this queuing model or waiting line theory. Okay, the problem is very simple. A fertilizer company distributes its products by trucks, and trucks are loaded and sent to distributor. It is found that on an average every 5 minutes one truck arrives. Every 5 minutes one truck arrives, and it takes 3 minutes to load one truck. It takes 3 minutes to load one truck. Okay, so if you see the pattern, it is average every 5 minutes one truck. Every 5 minutes one truck arrives. Okay, and right, every 5 minutes one truck arrives, and it takes 3 minutes to load one truck. So that is means by this way it is getting served. Okay, so loading is the service that has been given. Okay, arrival is one pattern and loading is another pattern. Okay, so whenever any of the problem of this category we have to solve under this queuing model, we want only two parameters. We want only the two parameters because every formula is basically based on these two parameters. Okay, so the first parameter that is required is arrival rate. Okay, arrival rate, which is represented by using lambda, which is represented by using lambda. And second we require the thing is service rate. Second thing is required is a service rate, which is represented by using mu. Okay, so by using this only two parameters, so we can easily solve any type of problem under this queuing model or waiting line theory. Okay, now the first parameter that we have to calculate is lambda, or the arrival rate. Okay, so the arrival is, I'm not saying arrival rate, it is a arrival is 5 minutes for one truck. That means for every 5 minutes, after every 5 minutes one truck is arriving. Okay, so it is not arrival rate. Okay, it is the frequency of the truck that has been given. That means for to arrive of the arrival of the one truck, it is taking 5 minutes. Okay, and we required arrival rate in the sense time is always going to be there in the denominator, at the denominator. Okay, so time is represented at the denominator side. Okay, but it is at the currently now in a numerator. Okay, so this is not the arrival rate. But apart from this, we have learned one more term. Okay, so that term is inter arrival rate. This is the inter arrival rate. Okay, so inter arrival rate and arrival rate are reciprocal to each other. Okay, so inter arrival rate is 5 minutes per truck. 5 minutes per truck, and we want a simply arrival rate. We want simply arrival rate, and as I have told earlier, reciprocal to each other. These are reciprocal to each other. Okay, so these are reciprocal to each other. Arrival is lambda and interarrival is 1 by lambda. Okay, so 1 by lambda is given as 5 minutes per truck. 5 minutes per truck. Okay, so if we want to calculate now arrival rate, which is represented by mu, then just we have to make a reciprocal of this. So 5 is to 1. Now we will make 1 is to 5. 1 is to 5, and the unit will be, now 1 is at the numerator, 5 is at the denominator. So 1 is to 5 trucks per minute. 1 is to 5 trucks per minute. You can convert it into hours also. Okay, so 1 by 5 trucks per minute. So simply it is 0.2 trucks per minute. 0.2 trucks per minute. So this is called as arrival rate. Now minutes is at the denominator. Okay, it can be in seconds. It can be in hours also. Okay, just by 0.2 trucks per minute. Okay, 0.2 trucks per minute. So it is lambda equal to 0.2 trucks per minute. Okay, so minutes will be at the denominator. Okay, so we will take it down here. We have got the value of lambda, that is 0.2 trucks per minute. Okay, so first thing, now it is clear that we got the value of lambda. Okay, just you will have to keep it in mind. Sometimes lambda is given directly, but sometimes lambda is given in terms of inter-arrival rate, that means 1 by lambda. Now the second thing that we have to calculate is service rate. Service rate, which is represented by mu. Okay, but now what is given? 3 minutes for one truck. What is given? 3 minutes to one truck. That means how trucks are getting service? One truck is requiring 3 minutes, so 3 minutes are required for one truck. Okay, so it is not again service rate. Okay, this is how the service is getting. Okay, time required for single truck, so it is again inter minutes for one truck, or the 3 minutes per truck. Now we want a service rate which is represented by using mu. Okay, so it can be taken as reciprocal of this 1 by 3, 1 by 3 trucks per minute, 1 by 3 trucks per minute. Okay, so it will be 0.33 trucks per minute, 0.33 trucks per minute. So we'll take it down. So 0.33 trucks per minute. So this will be called as a service rate. So we have got now our two required values. The first one is arrival rate lambda 0.2 trucks per minute, and service rate 0.33 trucks per minute, 0.33 trucks per minute. Okay, now first question is probability that truck has to wait. Probability that truck has to wait. Okay, that means truck has to wait means service station is busy. When truck has to wait, when service station or the service facility is busy, means traffic is there at this service facility. Traffic is there at service facility means we want traffic density. We want the traffic density means what is the probability that service facility is busy? Because if it is a busy, then only truck has to wait. If it is not busy, truck will directly get the service. Okay, that means it will be directly loaded. Okay, so traffic density is given by rho equal to lambda by mu. Okay, as already I have told, we want only the values of lambda and mu. Okay, so we have the value of lambda as 0.2 trucks per minute. We have the value of mu as 0.33 trucks per minute, 0.33 trucks per minute. Okay, so simply we will put all these two values in the given formula, that is traffic density rho equal to lambda by mu. Okay, so 0.2 divided by 0.33, and if we see the units, 0.2 has units as trucks per minute, 0.3 has units as trucks per minute. Okay, so it can be easily cancelled. Okay, so rho will not have the unit. Okay, so 0.2 divided by 0.3, 0.2 divided by 0.3, so it will be 0.60. Okay, 0.60, and this it has been asked as a probability. Okay, and generally probability is given in terms of percentage, so we'll have to multiply by 100. We'll get the 60.60%. We'll get the 60.60% as a probability of, or the probability that truck has to wait. That means there are the chances of 60% chances, 60.60% chances that truck has to wait. Truck calculated by using lambda by mu, that means 0.2 divided by 0.3, and it will multiplied by 100, and it is answer is 60.60%. 60.60%. Is average number of trucks in the system. Second question is average number of trucks. Average number of trucks in the system. system. Okay, so average number of trucks in the system. So average number of trucks in the system is lambda by mu minus lambda. Okay, this is the simple formula. Again, here only use of only two terms, lambda and mu. Okay, so 0.2 divided by 0.33 minus 0.2. Okay, so this can be calculated easily. This can be calculated easily. 0.2 divided by 0.33 minus 0.02. So 0.2 divided by 0.13, okay, because 0.33 minus 0.02 will be 0.13, okay, and this divisibility, that is 0.2 divided by 0.13, will come out as 1.538, okay, 1.538, okay. So average number of trucks in the system are 1.538, but trucks cannot be in a fraction. Number of trucks cannot be in a fraction. 1.538 trucks, so we have to make it approximately, that is 1.538 is approximately 2, because one truck is complete and 0.53 means second truck will be in a system for 50% of time, but there are going to be two trucks in the system, so approximately it will be equal to two trucks. Okay, third is average waiting time, average waiting time in queue, average waiting time in queue, okay, that is given by WQ, okay, and previous question can be written as LQ, sorry, LS, okay, that was the LS, okay, this is the WQ, waiting time in a queue. Okay, now we know the waiting time in a system, waiting time in a system is given by 1 by mu minus lambda. That means this is a waiting time in a system, this is waiting time in a system. But if we get the probability for which truck has to wait, truck has to wait, that means lambda by mu, then by multiplication of this we will get the probability for which, sorry, average waiting time in a queue. Okay, so lambda by mu already we have calculated as 0.6060, okay, multiplied by 1 divided by 0.33, 0.33 minus 0.2, so it will come out as 4.66 minutes, 4.66 minutes, 4.66 minutes. Okay, so that is the average waiting time in a queue, means this is going to be a waiting time in a queue for the trucks. Okay, if we want to calculate for system, it will be simply 1 by mu minus lambda, and if you, when you multiply by lambda minus lambda by mu, you will get in a queue. Okay, so system multiplied by lambda by mu is waiting time in a queue. Okay, so we got our three answers. Number of trucks in the system, 2.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.